Hi, I am M. Jagadish, Associate Professor in CSC Departments. Now here, in this session, we discuss about memory management operators. Memory management operator that indicates here, we are going to allocate the memory to the variables. In order to allocate the memory to the variables, it can be done in two ways. One is nothing much static memory allocation, and one more is nothing much dynamic memory allocation. So when we just go to work with memory allocation, then definitely we just go to make use of static memory allocation and dynamic memory allocation. Come to this one, static memory allocation. In the static memory allocation, it indicates we are going to allocate the memory to the variable at the time of program compilation. When we allocate the memory at the time of program compilation, we can call that is nothing but static memory allocation. Take the examples int a of 20. Int a of 20 that indicates here I am specifying a is the array variable, and that too this variable is going to store a maximum of 10 values, and all these values are of integer data type. So now integer data type capacity is 2 bytes. So 2 into 10, 20 bytes. Totally, when the program is going to compile, at the time of compilation, it reserves 20 bytes of memory in the name of a variable. So this type of allocation is nothing but static memory allocation. When we just go to specify the static memory allocation all the ways, it also specifies, it also generates some disadvantages. The first and foremost is nothing but wastage of memory. Assume now if I declare int a of 10, but I used only two values, that indicates only 4 bytes of memory I am using among 20 bytes of memory. The remaining bytes of memory is waste. So this is the one disadvantage. Similarly, take one more case. Now I declare a of 10, but I want to store 15 values or 20 values, but it is not capable to store 15 or 20 values. So this is also one more disadvantage. So with this disadvantage, we move towards the next memory allocation, that is nothing but dynamic memory allocation. Now we are at dynamic memory allocation. Dynamic memory allocation that indicates we are going to allocate the memory at the time of program execution. When we just go to allocate the memory at the time of program execution, we can call it nothing but dynamic memory allocation. And in C++, it provides two dynamic memory allocation operators. One is nothing but new, and one more is nothing but delete. This new and delete operators are used to allocate the memory dynamically and to deallocate or free memory dynamically. Dynamically means at the runtime. Come to the first one, what actually the necessity to make use of this dynamic memory allocation operators means. In real world applications, it is a major thing to use these dynamic memory allocation operators to work or to execute the applications efficiently. Now, basically the new operator, what it will do means, the new operator allocates the memory dynamically and returns a pointer to start of it. When we specify I am going to store or I am going to reserve 20 bytes of memory dynamically, then it reserves or allocates 20 bytes of memory to one particular variable, and the pointer will be placed at first memory allocation. That actually the meaning of this pointer to the start of it. And delete operator. This delete operator is used to release or free the memory which was allocated earlier by means of new operator. So this new and delete operators are used to allocate and deallocate the memory dynamically. Now, how we are going to use this new and delete operators that indicates, look at this particular one. Here we are going to specify the syntax how to use the new and delete operators. Now, come to the first one, syntax. Pointer variable is equal to new, which is a keyword which is used to allocate the memory, new, data type, and value. You can also assign or initialize the value at the time of declaration itself. Now look at this. Example, int pointer p is equal to new int of 25. That indicates I am specifying p is a pointer variable, and also I am specifying I am going to allocate or reserve the memory dynamically by specifying new operator. And that I am specifying how much memory that I am going to allocate by specifying a data type. So when I use the data type int, means it is going to reserve 2 bytes of memory, and in these 2 bytes of memory, the value 25 will be stored. Take one more example. Float pointer q. Float pointer q is equal to new float of 75.25. That indicates I am going to specify pointer q is a pointer variable which is used to store a data value of 75.25. To store a data value of 75.25, first of all, I must allocate the memory. So for that I am specifying new here. When I specify new, at the time of program execution, it allocates the memory. How much memory it allocates means based on data type what I am specifying here. Based on the data type what I used here. Here I am using the data type is float, means 4 bytes of memory will be reserved or allocated. And in this 4 bytes of memory, the value 75.25 will be stored. This is the way how we are going to use the new operator to allocate the memory dynamically. Now look at one more side, that is nothing much to release or deallocate the memory. When you want to delete the memory or release the memory, you can use delete operator. So delete pointer variable. So delete pointer variable means delete p, which is going to delete or remove the memory which was allocated earlier by means of new. Delete q will also deletes the memory or releases the memory which was allocated by the operator new. So likewise, we just go to allocate or deallocate the memory dynamically by means of new and delete operators. So look at the example program. Here we just go to illustrate the new and delete operators by means of example program. First statement hash include IO stream, which is a header file. Then namespace std using namespace std. Then main function. Here I am declaring the int pointer variable, int pointer point inch, and also I am declaring the float pointer variable, float pointer point floats, and also I just go to create the memory dynamically. Now observe clearly. Here I am using the new operator to allocate the memory dynamically to the variable point inch. And here I just go to specify how much memory is going to allocate means 2 bytes. Why? Because means here I am specifying the int data type. Similarly, point float is equal to new float. So again, I am going to allocate the memory dynamically to the variable point floats. And then I just go to specify the number of bytes are nothing but 4 by specifying the data type as float. So now for integer variable, it reserves 2 bytes of memory. For float variable, it reserves 4 bytes of memory. Now allocate or assign the value to those memory locations. Now point int is equal to 45 means 45 will be stored in the memory which was reserved earlier on the name of point inch. Similarly, pointer point floats is equal to 45.45f. That indicates I am storing the value 45.45 in the variable pointer point floats. Then when I just go to print the value by means of cout pointer point inch, it displays 45 on the output screen. Then end L. So end L means it's similar to slash end line. Now cout pointer point floats. Again pointer point float value is 45.45, which will be appeared on output screen by means of cout statements. Again end L, end line. Next, delete point inch point float. That indicates whatever the memory I created earlier, that memory is going to release by means of delete operator. So when I use delete operator, the memory will be releases or deletes, which is going to use by some other applications. Then return 0, close brace. Successful program execution. Then the output will be appears like this 45 and 45.45. This is the way how we just go to use the memory allocation operators new and deletes. Thank you.